Alright, so this lesson is going to walk you through the introduction on how to balance a chemical reaction. This goes with the first set of notes and balancing worksheet 1. So the purpose of balancing an equation is to show that mass is conserved. And so the first thing that I do is split up my starting material, what's on the left, which are my reactants, from the right. And so I drew that red line in to separate what I started with versus what I end with. What you need to do is list out what you have that makes up the reactant side. We have sulfur, we have oxygen, and we have sulfur and oxygen on the same materials on each side. When you take your initial count, we have 1 sulfur and 1 sulfur. Because I have that subscript 2, that means I have 2 sulfur or 2 oxygens on my reactant side. I have 3 oxygens on my product side. So our goal here is to make our inventory or our list to be equal on each side. So our sulfurs are currently equal. We have 1 to 1. However, our oxygen are not. So what we can do is add coefficients in the spots that I have in those lines to the left of the formula of the element or compound that we're working with. So they are not equal. Our goal here is we need to make them equal by adding a coefficient that multiplies by the subscript. Well, on the product side, I have 3, reactant side 2. There's nothing I can multiply by 2 to get to 3. That's a whole number. So then what I am looking at is what do these both go into? And these both go into 6. So what I need to do on the left-hand side is fill in what I can multiply by a subscript of 2 to get to 6. So if I put a 3 here, coefficient of 3 times 2 gives me 6 oxygen. On the opposite side, if I put a 2 here, 2 times my subscript 3 gives me 6 oxygen on the product side. However, anytime you add a coefficient, what you put in the front impacts everything in the formula. So not only do we have 6 oxygen, but we now have 2 sulfur. So I have to go back to my original part, and then I need to get my sulfurs balanced. So to do that, I'm going to put a coefficient of 2 on this side, and I now have a balanced chemical equation. Looking at the same thing in the next example, the first thing you do is separate it out. So I'm going to list the elements that I have. I have Na and I have I. I have 1 sodium on the reactant side. I have 2 iodine on the reactant side. On the product side, I have 1 sodium, 1 iodine. So going through to balance, my sodiums are equal. I don't need to do anything to balance it. The iodine are not balanced. I need more on the product side, on the right-hand side, so I need to add a coefficient. Coefficient of 2 will multiply to give me 2 sodium. Again, when I do that, that also changes my sodium. So then I need to go ahead and balance out my sodium. So if I put a coefficient of 2 here, that changes my sodium. Again, as soon as your inventory is equal, you are done. Taking a look at the next set of examples, we have nitrogen and oxygen. I have 2 nitrogen and 2 oxygen to begin with on the reactant side. I have 2 nitrogen and only 1 oxygen on the product side. So my nitrogens balance out, oxygens are not. Product side, I need to balance them, so I place a coefficient of 2 here. That changes it to 2 oxygen. That also changes my nitrogen. I take 2 times my subscript there, so that is now 4. Oxygen are balanced, nitrogen are not. I need to get to 4 on my reactant side, so by putting a coefficient of 2 there, multiplies and gives me 4, it is now balanced. The last example then is if we take a look here at number 4, we have aluminum and oxygen. 1 aluminum, 2 oxygen to begin, versus 2 aluminum and 3 oxygen to end with. So starting out, I would want to balance my aluminum. If I put a coefficient of 2 here, that fixes that. The oxygen is kind of like what we saw in the first example, where it's not going to work out that I can multiply by a whole coefficient. So I have to look at what do they both go into. These both go into 6. So again, how do you get that on that side? You're going to put a 3. On this side, a 2. When you do that, you need to update everything. So this also changed our number of aluminum. So we have to go back to the drawing board in that we need to change our coefficient here to balance it out. So I now have 4 aluminum on the product side, So to do that on the reactant side, I need to change that to a 4. And I now have a balanced chemical equation. The last example is an example of combustion. So these last ones, I'm going to do example 5 is what's called a combustion reaction. And so when it comes to how to balance carbon, hydrogen, and oxygen, always balance your oxygen last, hydrogen second to last. It makes things easier for you in the long run. So with your initial count, we have 1 carbon, 4 hydrogen, 2 oxygen. Product side would be 1 carbon, 2 hydrogen, and if you look carefully, we have a total of 2 oxygen plus the 1 in the water, so there's a grand total of 3. When you begin balancing, the carbons are equal, the hydrogens are not, so my coefficient here should be a 2. If I take 2 times my subscript 2, I get 4. Careful, when you look, this gives you 2 oxygen in the water and the 2 from the CO2, so this is now a 4. So now the last thing is to balance is the oxygen. So a coefficient of 2 multiplies by my subscript 2 to give me 4, and I now have a balanced equation. So this is the run through on how to balance equations, starting with worksheet 1.